All right, cool. I'm going to try to make up a little bit of time. We're running about 15 minutes behind schedule. I'm Roger Doherty. I'm a SQL Server technical evangelist. And hopefully over the next 45 minutes to an hour, I'll give you a good baseline understanding of what's happening with regards to SQL Azure database and related services on the Windows Azure platform. And I would like to invite you to ask questions whenever you like. I have one rule. If you want to ask a question, you got to come up and get this. Okay, so I'm going to leave this mic on the little side table over here, and you're free to come up and grab it and turn it on. And once you do that, you can ask questions at any time during the presentation, no problem. Okay? And we'll also take some time for Q&A during lunch. So let's start out with the basics. What is this SQL Azure database thing? SQL Azure database is SQL Server technology delivered as a service on the Windows Azure platform. And that's kind of a deceptively simple tagline, and I'm going to try to put some meat to what that means in a moment when we start talking about deployment. We look at SQL Azure as a great, database environment for both, very simple, web applications, all the way up to very complex, kind of scaled out, enterprise-grade solutions for the cloud. And in some ways, it's quite different from on-premise SQL Server. There's this huge amount of expertise that people build up in the database world to implement, say, high availability in their own environment. With SQL Azure, it's sort of like baked in. So as an example, when you create a database in SQL Azure, we automatically spin up 3 replicas of that database. Automatically. You have no choice in this, right? And if something happens with your primary, we will automatically promote one of those secondary replicas to the primary and route connections to the newly promoted primary, right? This is completely transparent to the application tier. You do absolutely nothing as a developer or programmer or DBA to make this happen. And it's not optional. It happens with every SQL Azure database that's out there. So when we talk about enterprise ready with automatic support for high availability, that's kind of what I'm talking about. In terms of the last bullet there, designed to scale out elastically on demand. So I'm a database guy. I've been at Microsoft 20 years. I've spent a career learning how to scale databases up on big iron and get more transactions per second out of these gigantic servers with big gobs of RAM and lots of CPUs and gigantic storage subsystems, right? That is not what the cloud's about. The cloud's about scaling out on kind of cheap, disposable, throwaway computing resources. So when you approach your database solution in the cloud, you have to rethink how you're going to scale the thing. You're not going to scale it up. That's not going to happen. There is no big iron. There's lots of small iron. Okay? And so you're going to have to scale that thing out over a bunch of databases. So we'll talk about, you can do that manually today, scale out, shard your own databases, create your own sharding pattern, but you have to do the hard work behind that. And we'll talk about how we've got some help on the way around that sharding in something called SQL Azure Federations. It's really easy to get started with SQL Azure. This is, one of the key adoption blockers for SQL Server is simply the time and energy and money it takes to purchase the hardware, purchase the software, install, configure, maintain, patch the software. I mean, that is a lot of work, and it's not something that gets done in a day. I will show you how you can deploy a SQL Azure database in about 30 seconds. Okay? So if you just want some database, this is ideal. You don't have to go negotiate with the IT department for a database server, all of that good stuff, right? So it's really, really easy to get started. So let's jump right in and start talking about the provisioning process. So when we talk about a server from a SQL Azure perspective, what are we talking about? A server is nothing but a service head. It's a connection point to go talk to some databases, right? And when you create this server, you automatically get a fully qualified domain name in the format that you see up there. So we're going to generate the name of the server, and it's going to have the fully qualified name of whatever the server name is, .database.windows.net. And initially, when you spin up this server, it's going to have one special database, which is called master, which is really only there for kind of like cataloging functionality. It just tells you all the other databases that you have laid out on that server. There's a couple different ways to provision your servers. You can do it interactively on the Windows Azure Management Portal. So you can see you've got a little database plugin down there on the left. When you click on that, you get that little server ribbon bar up top. You click Create. You basically give it some admin login credentials. You optionally configure some firewall rules, and bang, you got a server, right? So you can do it interactively through that, or you can do it in an automated fashion using the Windows Azure Platform PowerShell CMDlets. And these are a utility that our team, a guy named an evangelist named Michael Walsham, has built these things and is shipping them on Codeplex. And they call a REST management API that the same portal uses to provision servers. So you can do this as an automated fashion. So you can imagine if you're a SaaS application provider, in a few lines of code, you can provision a new database for a new tenant, right? Super easy, super straightforward. So let's show you what that provisioning process looks like. So here what I've got is PowerShell running. And I'm going to first just go in here and add the snap-ins for the Windows Azure PowerShell CMDlets. So those are now loaded up. And now I'm going to basically configure everything that I need to send to the management API to communicate with my subscription. So I've got a subscription ID, which I pulled right out of the management portal. I've got a thumbprint for a management certificate, which is how we're going to do authentication, right? So I actually provision that management certificate in advance just to make this demo go a little bit faster. I give a user ID for my newly provisioned server, and I provide a password. And so you all are seeing my username and my login ID and my password here, so I'm hoping that you'll be nice. So my password is Azure Camps Peeps Be Nice 1. Okay? So we're going to provision this in a particular data center. You can get this list from the GUI and the portal, but you have a choice of all the different data centers across the world of where you want to deploy this or provision this new server. And then you provide an IP address. So actually that IP address was the one I had back in the hotel. So let's find out what my current IP address is. It's this guy right here. And I'll probably get like 500 pop-up ads for using this site. So what I'm doing here is I'm basically saying, look, lock down connectivity to this thing. That's kind of odd. I want to make sure that that's right. Lock down connectivity to this thing to only this particular IP address. Do not allow anybody else to get in here. All right, well, I guess it is what it is. Oh, I know why this is, because I'm running this thing in a data center in North Carolina. This is not my actual machine that we're on. We're on a hosted machine here. So the IP address is actually the same. So, okay, I've got all my variables laid out, and then we'll go ahead and set up the values of those now that my CMDlets are loaded. Now, the first thing that I do is I go grab that management certificate that I provisioned in advance. I've got a copy of that stored on this machine and a copy that's already been uploaded and configured in the Windows Azure Management Portal. So I pull that cert in, and then here's the one command to provision a new SQL Azure server. This is it. And I print out the name of that server, and let's try this and see if this runs. So at this point, our PowerShell CMDlets are up there kind of running and executing operations against the management REST API. and my server's been provisioned. And that's my new server name. Now, compare that to purchasing a server, purchasing database server software, purchasing operating system software, rolling the whole thing out, licensing the whole thing. Maybe a week later, you've got a machine that you can go and talk to do some database, right? We just did this in what, 30 seconds? That's platform as a service, right? It's very, very cool. So I've gone ahead and created that. Let's go ahead and provision a few firewall rules. So we'll go in here and add a firewall rule for my IP address. Cool. Now I should be able to connect up to this thing. So what was my new server name? It's up here, this guy right here. Let's go copy that. And let's go just test connectivity to this server. So maybe I'll pull up, yeah, I can do it here. We'll just do a command line connection with SQL CMD. A lot of the same SQL Server utilities and tools work against SQL Azure as you use against your on-premise SQL Server installation. So I'm going to go ahead and paste in the name of that new server, .database.windows.net, my user, DPE admin, my password, Azure Camps Peeps Be Nice 1. We're connected. Select name from sys.databases. Bang. I got some fully functional SQL Server. Right? So that's cool. So I just want to give you a feel for what platform as a service meant and what we mean when we talk about SQL Server database technology delivered as a service on the Windows Azure platform, right? Because it's an easy thing to say, but until you actually see that, you don't really know what you're talking about. Okay, cool. So we'll switch back to the deck. And there we go. So we've gone ahead and we've provisioned our server. Now it's time to build your database, right? How do you do that? Just as a little bit of background, if you've already built some SQL Server databases in the past, you have a lot of the knowledge that you already need to build a SQL Azure database. It supports Transact SQL. The data access APIs that you can use to program against SQL Azure are very similar and pretty much the same ones that work for SQL Server. So you're talking about .NET Framework code or managed code through the ADO.NET API in .NET. If you're a native code developer, it's all about ODBC. So we have an ODBC driver that you can use to connect up. If you're a Java developer, we have a very functional Java driver that you can use and a very functional PHP driver that you can use as well. And as James mentioned earlier this morning, the only one of those things that's actually in a web role or a worker role when you provision it is the first one, right? And an old version of the second one. So one of the things you may need to think about doing in your startup tasks is provisioning new data access providers or more recent versions of them, right? Because we don't have those latest versions always available at all times in the web roles and the worker roles. So if you're a developer and you can't see yourself writing Transact SQL code in your beautiful managed or native code, and you want to use a framework for that, you can do that. We've got OData for REST data access, so you can actually build HTTP interfaces to go at your data. Underneath OData is the entity framework and WCF data services, so you can actually essentially serve up your data as a service using those APIs. And Hibernate works great on SQL Azure. Fully compliant, fully passed their test suite. So if you're an Hibernate developer, rock and roll, right? Also, it supports popular tools like Management Studio, the command line utilities. You've already seen SQL CMD. And then popular third-party database modeling tools are also announcing support for SQL Azure. So things like the Irwin Data Modeler and DB Artisan from Embarcadero. There are some differences. I'm not going to dwell on these. I don't want to take a lot of time on this, but the differences in some ways are good. You're focused on logical administration, not physical administration. So when you create a database, you're not worrying about the spindles underneath. You're not placing your data files on storage. We're doing that for you. You got to give that up. Just let it go, right? So that's goodness. So those database and log files are automatically placed for you. We automatically do the replicas. We talked about that. The bullet about databases being fully contained is extremely important. We're going to start off on the right foot with SQL Azure. With SQL Server, we sprinkled a lot of stuff in over these past 20 years that lets you take dependencies on objects outside of the database. It turns out this is really not good from a high availability perspective. When you have this spider web of dependencies, when your database is pointing to all of these things outside of itself, how do you fail it over reliably? The answer is you don't. You fail it over, and then you go fix all those dependencies, right? And that's a nightmare. So we're going to enforce some hygiene here. And you're not allowed to talk to objects outside of SQL Azure, period. All your database objects must be self-contained. Now, if you're one of these people that separated your schema objects for logical reasons, we have a way for you to do that in SQL Azure and in SQL Server using logical database schemas. So we'll talk about that as well. Another difference, all tables in SQL Azure require a clustered index, all of them. Why? That's how we do the replicas, right? So make sure when you're doing your table definitions that you include a clustered index with everything. Right now, the maximum database size is 50 gigs. We're going to push that up, but remember, we're scaling out, not scaling up. You may look at that and say, that's a joke. I need 40 terabyte maximum size database, right? Guess what? You can have that with a bunch of separate databases, right? Individual databases are going to be limited to, I would say, a fairly small size. And you're going to have to partition your data across them. Okay? And that's how you scale out in the cloud. This is not big iron. This is cheap throwaway, cloud computing resources, right? So you got to rethink that. There's some stuff that you might expect to be able to do against SQL Azure that you can't. Backup and restore is one of them. And a lot of people are like, whoa, can't back up my database? Relax, yes. It's just a different approach, okay? So we do have some other capabilities for doing that. Because the databases are fully contained, you can't do the stuff in the second bullet there. You can't do all this stuff here because this introduces dependencies to stuff that's outside the database, right? And that's badness. And we're trying to enforce good contained database hygiene, right? So that stuff is turned off. And there's a few advanced capabilities like Service Broker, like CLR and SQL Agent that we're just not going to turn on yet because we're not really sure if we can do that in a reliable, high-performance way in the cloud, right? So if you're one of these SQL Server geeks like me that has used every knob, dial, and widget in SQL Server, you may have to kind of pull back a little bit, simplify your database a little bit, get rid of some of the special gadgets and widgets, and do a little bit more of a simplified data model to get your database up here. And that will be a roadblock that many of you will experience when you initially move to SQL Azure. And I'm trying to tell you that that's a good thing. I'm trying to position the pain as good pain, right? Because it's enforcing that hygiene. Cool. So let's talk about then the tools that you would actually use to build your database. We recently released a new portal experience. So we have a new thin client designers that you can basically go out, build tables, build views, build stored procedures right through the SQL Azure portal itself without installing any tools whatsoever on your box. So if I'm a web developer and I just need a simple couple tables, I need to bang some data in there, no problem. You can use these tools to do it. And I actually really like the UI for these things, so I would definitely have you check out this new portal experience. We had one before that was kind of like an acid trip. It was like a really weird Silverlight application with spinning cubes, and that's gone, and we have actually a properly designed portal experience now. I know some people are unhappy that the acid trip is gone. I apologize. All right. The other way is if you're building a little bit more of a robust solution with that needs source control and all that, is with the new SQL Server Data Tools, or SSDT. This is a Visual Studio-based IDE for doing database development. And what we're trying to do is bring database development out of the 80s and into the year, 2011. Okay? So C# developers, when they're defining their classes, and they reference a class, if that class doesn't exist, they know the instance that they typed the wrong class name, that they did something wrong. They don't even have to build their code. Why? Because we maintain a model of that whole C# project in memory to make the developer more productive. That's what we're doing in SQL Server Data Tools. We're going to maintain an in-memory model of your database that allows you to develop declaratively over it and do very powerful refactoring operations, really understand the object dependencies between things, and it really improves the experience. Importantly, you can begin developing your database applications either in a connected way or a disconnected way. So you don't even have to have a SQL Azure server in the picture to start building a SQL Azure database. And as a matter of fact, James talked earlier this morning about some of the emulators that we have with the Windows Azure SDK. And SQL Server's getting ready to ship a new lightweight version of SQL Server called the Local Database Runtime, which you could kind of use in that same way. You could deploy your stuff to the local database runtime to test it just on your box without even installing SQL Server, right? That local database runtime ships in the box with SQL Server Data Tools. A big benefit of using SSDT is platform targeting. I'd like to say that Transact SQL is Transact SQL everywhere. That's not the case. We got different flavors of Transact SQL. Now we got this new thing, SQL Azure. It's got its own kind of quirks and differences to it. How are you as a developer to know what stuff you can use and what you can't, right? The old approach is write the script, execute it, and cross your fingers. That is not a modern development experience, right? So what we're implementing in SSDT is platform targeting. You set the target, right? And if you're doing something that is not kosher on that target, we will tell you immediately before you run it or before you try to deploy it. Okay? So this new tool is available free with the web platform installer, with SQL Server 2012, and with Visual Studio 11. If you go into the web platform installer, into products database, you'll actually see a pre-release version of that. It's codenamed Juno. And I would suggest checking it out. It's very cool. And that one works with Visual Studio 2010. So after I develop my database, then it's time to deploy it. And we're also trying to bring database migration, deployment, and versioning into the year 2011 and get it out of that manual script-based world. That's what the data tier application framework is all about. Nobody knows about this, and to me it's the coolest sleeper developer technology for SQL Server to come out in the past 10 years. So you are the privileged few to know about what the data tier application framework is. And I'm going to demo it to you today. So it's an alternative to that traditional script-based approach. It dramatically simplifies the deployment, migration, and versioning of your databases. It gives you a single unit of deployment for your database schema called a DAC pack. Or if you want to also package up some data with that and deploy both schema and data, that's called a backpack, right? And it supports automatic versioning of database schemas. So after I've deployed my database and it's been in production for a while, my developers go off and they make changes to the schema. And usually when they test it, they create a nice new pristine database, right? Not a dirty database that's been in production and gone through 3 version changes since I first deployed it, right? So they do their testing on this nice pristine database schema, then they hand the thing off to whoever's going to do the deployment, and they say, you figure it out. You figure out how to get from point A to point B, right? And it's really hard, and it's extremely time-consuming. The data tier application framework is designed to start carrying some of that water for you. So I will show you what that's all about. It supports platform targeting like SSDT, and you can build these data tier applications from scratch in the development environment, or you can reverse engineer them from existing databases. So like, hey, here's a database, I kind of want to DACify it, go extract all the schema and build me a DAC, right? So we'll show you kind of what that's all about. So how to get the latest stuff with the data tier application framework. It ships in the box with the SQL Server data tools. It ships with SQL Server 2012 Management Studio, which is currently in community CTP state, so it's pre-release. And it also has been deployed on the Windows Azure platform as a service, a pre-release service called the SQL Azure Import-Export Service. So I'll show you what that looks like. If you want to play with some of the stuff that I'll show you in the demo, go up to this CodePlex site. Some of the command line executables up there will save you lots and lots of time and energy. Okay? It's called SQLDACexamples.codeplex.com. All right, so let's talk about the build, deploy. Actually, maybe I'll do one more slide. So I build up my DAC pack. I can deploy that DAC pack interactively using the SQL Azure portal. So you can see here, when I'm in managing my database, I can choose this deployment option right here, point to the DAC, and it just hydrates the database for me, right? No running scripts, right? Single unit of deployment there. If you use that approach, you have to load the data as a separate process, okay? Because DACs are schema only. And SQL Server 2012 Management Studio also supports deployment using that approach. There's also an interactive approach for backpacks. Backpacks are schema plus data, right? So here you basically create your backpack, you upload it to Windows Azure Blob Storage, you log into the Windows Azure Management Portal, and then you choose this little import option right here when you're in there managing your SQL Azure database. And it reads the thing out of blob storage and does the deployment in the cloud. So you don't have like a little laptop sitting on your desk, pumping gigabytes of data into some SQL server, right? It's a service on the back end doing it for you. That's huge. Big deal. And you can also export to blob storage. This is the poor man's backup that I referenced earlier. So I can't say backup database, but I can export my entire database to a backpack and store that in Windows Azure Blob Storage and sort of like keep it as a version or a snapshot of my database. And we'll have even richer kind of backup and recovery options in the future, but right now, that's what you got. Okay? Cool. So finally, the real payoff of using this data tier application framework is when you want to move to a new version of your schema. So basically, the data tier application framework will give you tools for migrating from version 0 to version 1 of your database schema, even for a production installation, right? This right now is a command line only kind of capability. Using the CodePlex site that I showed you, there's some tools up there to do it, right? So I will show you a demo of how that works. All of this stuff will be completely integrated into the portals and the tools moving forward. So there's a few rough edges in this experience right now, but we're getting there. I think what I want to do now is actually show you a demo. So what I've got here is Visual Studio 2010 with a project, and that project has a new SQL Server Data Tools database project in it. And you can see here, each of my objects in my database are represented as a separate code fragment. And I have some nice new designers. Here's the new table designer, which I can interactively use to create my table structures. I can work in the graphical view or in the code view, and we synchronize them automatically. You can switch which one you want to work in, code or graphical mode. Very nice capability, right? I can check all these things into source control, all that good stuff, right? And then I've got an on-premise web application that I've built that uses that database. So it's a very simple hello world kind of web application that does CRUD operations. So I can go in and say add a new Connect bike to my local SQL Server database. And what does a Connect bike look like, you ask? It looks like this. Okay, so just a simple insert, update, delete kind of operations, right? So that's my web app. There's some other pieces I'll show you a little bit later, but that's how the thing works. Now, the evidence that I've deployed that on-premise, I can see here in the new SQL Server Explorer that comes with SQL Server Data Tools. That gives me everything I need from, like, in other words, I no longer need to install Management Studio. I can do everything I need to do against SQL Server as a developer from this node. It's not a half-hearted implementation anymore. It's a full-blown implementation, right? So I can go in here and I can see that I've already deployed a DAC associated with that database. That DAC has been registered with my on-premise SQL Server instance, and I've hydrated the database associated with that DAC. So here's the actual physical representation of that database. And I can go in and kind of browse it. I can go check the data out that's in this table. We have nice tooling around this database experience from a connected perspective as well, right? So great. I've deployed this thing on premise. What is it going to take for me to move this thing up to the cloud? I'm running a 2-line script that uses a couple of those exes from that Codeplex site. And what this 2-line script is going to do for us is extract the DAC from my on-premise installation of SQL Server and also copy out all the table data and bundle that up with the DAC in a new file format called Backpack. So here you can see productsdb.backpack has been created. It takes that one file and pushes it up to SQL Azure. Okay? And what happens there is it registers the DAC, hydrates the database, and then you'll see it start loading the table data. Right? No more, running scripts, no more BCP, no more, it's just here's your file that represents your database, go deploy it. Right? Now I'm doing this in a command line way from the client. You can also do this through the Windows Azure Management Portal using that SQL Azure import-export service as well, right? So you'll see somewhat not so great performance here because we're running all this stuff from my client, basically. This would be a lot faster if we were running it up in the data center. So here it goes. It's unpacking the table data, populating all the tables, and now I've got my database deployed up on the Windows Azure platform. So when I go up there to the Windows Azure platform, I can see if I go into database here, I've deployed that to one of my SQL Azure instances, which is this guy. And we can now see that the productsdb database has been deployed up there, which is awesome. And it's ready to roll, ready for me to use. I've deployed a couple of other things in advance, like the web application and some other pieces. But I just wanted to show you how the database piece works. So usually, no sooner have you done a deployment than you need to make a change. And this is where everything falls apart, typically, with databases, right? So what I can do here with SQL Server Data Tools and the Data Tier Application Framework is really powerful. Let's do something stupid and naive. Let's delete a column from the products table. Now, I might be a naive developer and think that that's actually totally fine for me to do. But what if I have other dependent objects that reference that column? I've just broken some stored procedures. I've broken some views. Because SQL Server Data Tools allows me to develop declaratively over a model of the database, I know immediately when I've done something naughty. Right? So here's an error that I just deleted a column that was referenced by a view. I double-click on that. It pops the view up. And I get the offensive column here listed. Just delete that guy. And I should be good, with my change. Has my errors gone away? Yep, they've gone away. I haven't even done a build yet, by the way. This is all in memory, an in-memory model of the database. So let's get to deploying this thing. I'm going to go here to Properties, fix up a couple things. First thing I'm going to do is go say, look, you know what? We're targeting Azure now, So I want to make sure I'm not doing anything that SQL Azure is going to complain about. So I set the target platform to SQL Azure. Check my errors, no errors. We're good. Awesome. Demo land. Now, if I had, for example, some tables in here that didn't have clustered indexes, I'd get errors right now. Don't try to deploy this thing up to Azure, dude, until you put some clustered indexes on here, right? Notice the build format. I'm not building transact SQL scripts. I'm building DAX, my single unit of deployment, right? And let's go version that. So I'm going to version it from the 1.0 to the 1.1 version, and we'll have some comments in here that let us know what's different about this particular version of my schema. We've got a deprecated column, right? And let's do a build. I could also test this thing locally using the local database runtime, which is right here. I want to, just in the interest of time, skip that, but like the whole emulator scenario that James talked about earlier, this gives you the ability to actually connect up your application if you want to this local database runtime and see if it even works before you even deploy it or even have a SQL Server installed on your machine. Very cool, right? So we'll go ahead and, did I already do a build? I'll do it again just in case my build succeeded. Let's go look at what the output of that build is. So I open up my Explorer here, we go into bin, we go into debug, and here's my DAC pack. That's the output of my build, schema only. Remember, DAC pack is schema only. If I went in and inspected this thing, it's just a zip file with some XML schema in there that describes all of the objects in the database the way I, the developer, have declared them to be. It's the blessed version of my schema, right? Now let's say we've got some controls in place that say that the developer is not allowed to monkey with the production system. The person that monkeys with the production system is the DBA. And what tool would they typically use? Typically they would use SQL Server Management Studio. So here's the new SQL Server 2012 version of Management Studio. And here's, I'm connected up to my SQL Azure database. If I go into Management here and pull up a list of all the DACs that I have installed, we see here that we have ProductsDB 1.0 installed. How, as a DBA, am I going to get from 1.0 to 1.1? It's a simple upgrade operation. Right-click, upgrade, point it to the new version of my DAC. Get some visual notification here. Yep, this is the one that we just built. It's the .1 with the deprecated column, right? And now we're detecting drift. Drift is some moron went into my database after I deployed it and put some detritus in there, some new tables and some new stored procedures and whatever else, right? Outside of the scope of my development project. That's badness, right? We can't prevent that from happening if somebody has privileges to do that, but we can warn you if it has happened. And that's what we're doing right now. We're scanning things and trying to determine if there was drift. If we detect the drift, which we didn't, you could then stop at this point and either go take care of that by deleting that stuff or create a new version of the DAC where you reverse engineer that drift back into your project. Yes, you would see the actual things. You could get a little report here of what the drift is, right? So this says there's been no drift. We're in demo land, right? So there's no drift. In the real world, there probably is. Next, very significant choice. I can upgrade in place, which is the default option, which means there's no going back. So I run this thing, you're done. There's no, oops, I didn't really mean to upgrade that database, right? If you might actually want to go back, you need to choose this rollback option, which is a side-by-side upgrade. We'll create a new empty database, create all the new schema objects in it, copy the data over, right, and then swap the names and leave the old one laying around. Fine if you got a little 1 gig database. Not so fine if you've got, a 50 gig database, right? So we give you a choice there. Cool. So we're going to go upgrade in place. Next thing, all the heavy lifting of the upgrade process is now figured out by the data tier application framework. I don't have to go and hand code database migration scripts to get me from .0 to .1 of my database schema. The data tier application framework figures all of that out for me. So this is the real payoff, frankly, of moving to DEX. You do get an easier movement of your schema and your data around with the DAC packs and the backpacks. That's nice. But this thing is the real payoff. Notice, here's the 50 things that have to happen that I would have had to have coded my own upgrade script to do, right? And this one is a nasty because I'm deleting a column, and that data is never coming back, right? So it makes me say, yeah, I really do know what I'm doing when I delete this column, and I do understand that data is going away forever and it's not coming back. Cool. Get a nice summary, bang. Go version the database. Done. Check that DAC pack into source control. Use it as, hey, this was the version of the database that we deployed on March the 7th for tenant XYZ insurance company. Right? Done. This is in place. This is happening in place, not side by side. Who asked the question? Sorry. You broke my rule, my friend. You got to come up and get the mic. This is an in-place upgrade. Okay? So there's no copying of data happening here. Okay? So it does it. We're all good. We migrated our schema, and we're all set. Awesome. Now if I refresh this view in Management Studio, we've got .1 of our DAC installed. Cool. So let's go see if our app works. So I go back into my management portal, and beforehand I went ahead and deployed a web role with that same ugly web app in it. If I click on that, here's the same web application that I was running on premise, running in the Windows Azure platform, talking to SQL Azure database. All the same technologies, ASP.NET, ADO.NET, Transact SQL, it's all the same. So inserts, updates, and deletes work just fine. Okay? So what you've seen is how the data tier application framework makes it easy for you to build, manage, and version your database schemas. You've seen how the new SQL Server developer tools really provide a modern development experience for building database solutions. And we're pretty excited about this stuff. When you take a run at this, you will find rough edges. This stuff is definitely not perfect, and you might gash yourself a couple of times. But once you kind of learn those areas that we haven't quite finished off yet, you're going to be fine, right? So after you've deployed your database, it's time to secure it. We've got a 2-level security kind of setup with SQL Azure. So essentially, you need to go in first and set up your logins. And that's all done in the master database. So you first connect up to that logical server with a login. And then, once you are connected up to the logical server, your login must be authorized and must be associated with a user account in the individual database in order to use anything, right? So it's a 2-step process. Create login and create user. And create user references the login. Okay? So if you're not a SQL Server person, this might be a bit of a mind scrambler. We actually think that this is kind of stupid. Why not just provision your security principles right in the database? And that's the direction that we're headed. As a matter of fact, the next release of SQL Server will offer this concept of a contained user where you connect straight to the database. You don't even go through a server. Okay? So that will eventually make its way out onto the Windows Azure platform as well. These demos that I'm showing you where we're connecting with the administrator account, bad. Don't do that. Create identities for your application and only grant them the privileges that they actually need, right? Don't just open up your database for any kind of activity or option. So once you're done there, connecting up your application is really easy. It's just, SQL Azure talks the tabular data stream protocol. We do require SSL and, to get through our load balancers, our gateways, and our routers. SSL is required. You have to have an appropriate firewall rule to connect. That's the first way people shoot themselves in the foot with SQL Azure, is they forget to set up a firewall rule, right? And then finally, all you got to do is modify your connection string. So, ASP.NET's going to use ADO.NET to talk to SQL Server. It's just a connection string with the new format for the database server, and notice encryption set to true down there on the bottom. Other than that, it's just a SQL Server. That's all it is. Works exactly the same. Really straightforward stuff. Cool. So some considerations. And I don't want to spend a lot of time on these because we're running out of time. There are scenarios where you've got an old app out there that uses a legacy provider that doesn't talk the new version of TDS that's in the next release of SQL Server and that's in SQL Azure. For those, you may have to provide the login as in a special format, as you can see there. And we do stuff. You're running in a shared configuration now. We're not just going to let people run rampant and consume all of the resources in the data center, right? So we do things like we terminate idle connections. We terminate long-running connections or long-running transactions that run at more than 24 hours long. We've got a denial of service guard that basically sits there and tries to detect DOS attacks and closes connections that it suspects are DOS attacks, right? If you've got some kind of failover event, that's going to terminate connections and you're going to need to retry. So you're going to want to make sure that you have really good connection retry logic. If you're using ASP.NET, that just uses connection pooling. So you don't really have to do anything there. But if you've got a more rigid app that doesn't use connection pooling, you're going to need to do some things. So the other thing here is, set your expectations right. This is not big iron. Okay, this is cheap throwaway iron, right? You're not going to do 2 million transactions per second in SQL Azure, especially because we've got these replicas out there. When I say commit transaction, I got to do a write across 4 replicas of my database, the primary and the 3 secondaries, before I'll actually allow that transaction to commit. Okay? So you're going to see some differences in throughput based upon that. You can't turn that off, right? So certain performance-sensitive database solutions, you may want to keep those on-premise for a while and only move the stuff up there that doesn't need those extremely high transactional throughput volume rates, right? And the whole thing about contained database, which we talked about. So just want to give you a taste for some of the other stuff that's happening in the platform around SQL Azure. We're improving our operational and our engineering efficiencies kind of like exponentially as we go. Just having a chat with one of the attendees about that. The rate at which we're coming out with improvements, the rate at which we're fixing problems is increasing. We have a quarterly service update cadence. Some of that stuff is like bug fixing. Some of it's new functionality. So this whole drum roll, the new release of SQL Server 5 years from now, that's over. You get new stuff every quarter, pretty much. Sometimes you get a bunch of new stuff, and sometimes you get just a few new things, right? That's the world of the cloud there. So we've got a bunch. The idea here is that we're also providing a lot of powerful value-added services that extend what you can do with SQL Azure. So, for example, you can buy and sell finished data sets on the Windows Azure Marketplace. So you can go up there and consume them. If you've got an interesting data set that you think other people would be interested in using, you can publish it up there and make money off of it. You can visualize your data with SQL Azure Reporting. You can synchronize your data with SQL Azure Data Sync. And you can scale your data out with SQL Azure Federations. And we'll talk about all of those. So the combination of these things really enable and power new opportunities for developers to basically build services that power up these devices and make them continuously available. New opportunities for building consumer apps and new opportunities for building line of business software as a service applications. So SQL Azure Reporting, I could talk about that, but I'm actually just going to show you really quickly because we're kind of running out of time here. Remember this on-premise app that I had? If I go in here and I debug this thing, it's the same little ugly web app that we looked at before. Notice I had a link here to a product safety report. And I can click on that, and we get some nice visualization of our product catalog data. That is being rendered by an on-premise installation of SQL Server reporting services, which has always, by the way, been implemented as a web service, right? You create a report definition, you deploy it to the report server, and then you call web services APIs to render it and take the rendered results back to the user, right? In this case, the user is an embedded user as part of my ASP.NET application. If you think you can sling web code to do reports prettier than this, faster than I can, I can tell you I will beat you hands down every time, right? So reporting services makes this kind of stuff really easy. What you're seeing here, this container here, is the report viewer control. This gives you all kinds of interesting paging and search functionality, and I can also export my report out to an Excel spreadsheet, to a Word document, save a copy, email it to my boss. That all comes for free with the Visual Studio Report Viewer Control. Very cool, right? So the way you build these reports, pretty straightforward. Actually, let me drop out of that app that I was just debugging. You'll notice here in my project, for my on-premise project, I've got the report designer installed, and here's the definition of my report. It could just be part of my project, right? And I've laid this report out, I've set up the design of this report, and it all works great in an on-premise world. Well, notice as well that I have a cloud version of that same report. And it's essentially identical, except for the way that it connects to the server. It uses SQL Server authentication instead of using integrated Windows authentication. But it's the same report. I've taken this report, and I've deployed it up to the Windows Azure platform. And you'll see here we have a new CTP of SQL Azure Reporting. SQL Azure Reporting is SQL Server reporting services technology delivered as a service on the Windows Azure platform. I can provision servers very quickly with it, just like I can SQL Azure servers. And notice I've deployed this report in advance up to, and you can see it here in my report catalog in this new management API, management portal experience. Here's my report. It's already been deployed. So I can now go up to my Windows Azure application that's running up in Windows Azure, and I can have the same reporting experience. But this time, it's calling SQL Azure Reporting, not an on-premise installation of SQL Server reporting services. Right? Same report, same functionality, same skills from a developer perspective required to build it. Right? But now completely running with no local hardware, using a platform as a service model up in the Windows Azure platform. So that is SQL Azure Reporting. Cool. I'm going to skip through some of this. You'll have these slides. So another use case of this stuff is some synchronization capabilities. So I've already told you kind of need to scale that out. Maybe you might have some data sets that are unique to Western Europe, and you only want the Western Europe data in the Western Europe SQL Azure database, and you only want the US data in the SQL Azure US database. And you have somebody else who isn't even in the cloud with an on-premise SQL Server installation. You want to replicate or synchronize some data down there. That's what you do with SQL Azure Data Sync. So essentially, it uses a hub-and-spoke topology and essentially gives you the ability to do either bidirectional or unidirectional synchronization between these clients, right? You always have to have a hub, right? So you set that hub up first, and then you start adding clients to it. Each of these, you have to define the directionality of each of these arrows here. Is it bidirectional? Does it come from the client? Does it come from the hub, right? And you have to define some policy, and then define which data actually gets synchronized. So let's go take a look at what that actually looks like. So here I am in my Windows Azure Management Portal. You can see we've got the new Data Sync Management Portal experience live. It is the coolest portal experience I've seen on the Windows Azure platform, both from a deployment and from an operational perspective. And I've set up a new sync group called Azure Camp. And in that sync group, we've got this topology. We've got a hub running in the north central US data center, and that's kind of like the master copy of my data, right? I've got a client running in SQL Azure in the south central US data center, and look at this. I got a client running on an on-premise installation of SQL Server, right? You set up the topology, you define the data set, and the data set is nothing but a definition of the tables and the columns that you want to synchronize, and then you can also define filtering rules. And this is where you would say only synchronize the Western Europe data to Western Europe, and only synchronize the US data to the US, right? So you define that, and then you can set up a schedule. Right now I'm doing manual synchronization. I can just say sync now, and you'll see operationally I get visual feedback of what's happening in the sync operation, right? Since it's hub and spoke, if the data modification occurs at one of the clients, it's going to take 2 hops or 2 sync operations for it to get out to all the clients. Everything goes to the hub first on the first sync, and then it gets distributed out to the clients on the second sync, right? We got nice kind of logging and tooling around here to see what's happening. If we had time, we'd go in and make some changes, and I'd show you the data propagating around all over the place, but I want to try to make up some time. So I'm going to skip that piece. So that's SQL Azure Data Sync. The last kind of advanced capability I want to talk about is something we call SQL Azure Federations. So what this is integrated database sharding that you can use to scale to hundreds of SQL Azure nodes, okay? To partition your data out across multiple SQL Azure nodes. Right? You can do this manually today, but a lot of people don't like doing all the heavy lifting of the application tier work required to route your connections to the right shards and all of those kinds of things, right? So this gives you the ability to do things like multi-tenancy. So here in the graphic, we actually have 2 federations. We have one federation based upon tenant. And you can see here, this might be one charge model, where I've got a single SQL Azure node hosting the data for 2 tenants. Maybe I charge them $10 a month each for that. Look at the second one. The second one is I've got a tenant with all his data on one SQL Azure node. Maybe I charge that guy $20 a month. Right? Look at the third one. The third one is one tenant with their data sharded across 2 nodes. Maybe that's, $20 per node, $40 a month that I charge that person, right? As a SaaS application provider, you could architect your system to implement this kind of billing and scalability model, right? So SQL Azure Federations is really flexible in terms of how you would do that. So rather than kind of talk through this stuff because we're really running out of time, let me just show you very, very quickly what this stuff looks like. So what we're going to do is we're going to create a new SQL Azure database called Azure Camp Sharding 2. Probably need to connect back up here. Let me just close this out and reconnect. Okay, cool. So we're going to create an Azure Camp Sharding 2 database. And the first thing that we're going to do before we put any data in there is create this federation. And the way that you federate can be either based upon an integer, a GUID. It doesn't, how you federate is up to you, right? So in this case, maybe my customer ID is like a tenant, and the possible number of tenants I could have would be limited by the range of big int values that I could have, right? There's no theoretical limit to the number of shards that you can have. So I'll create this federation, and this is the scheme. Oh, wait, I have to actually switch to that database first. This is the actual scheme that I'm going to use for sharding. Still don't have any data in there. Now, the thing that we're doing for you is connection routing, because these are all different nodes, right? You're spreading your data out a bunch of different SQL Azure nodes. So when you're connected, you need to be routed to the right shard. So in your code, you're going to be doing stuff like this. Take me back up to the root so that my context isn't associated with any particular shard, right? And once we're up there, we can look at some metadata that tells us how things are configured. And we can see here that I've got one federation scheme, and that federation scheme has one member. So all of my data for that customer ID federation will go into one federation member at this point with this range of values, the complete range for big ints, right? And so how do I actually get to a shard? This is how you do it. You actually go in and say, look, I'm working with customer ID 100 now, so take me to that shard. Well, this is kind of fake right now because there's no data, right? And there's only one shard. So any number there, any big int number there would have taken us to the same shard, okay? So we're now actually, the context of our connection is inside that first shard that was created for that customer ID federation. Now let's go define some tables. So here's a customer table, and notice I have this new federated clause. It tells me that this particular table is federated, okay? And let's go insert some data. So insert a bunch of customers. We're going to start with customer ID 56, and we're going to go all the way up to customer ID 210. So we got like 65 customers in there, right? And right now, in this particular shard, I have all of my customers in one place. So if I get the min and max customer ID, in the current context, the current connection context, the min is 56, the max is 210. And that's all the data that I just inserted, right? So now we'll reset our context, go back up to the root, and this is the cool stuff. In one command, I'm going to split. And one SQL Azure node will now become two. And everything to the left of 100 will wind up in one shard, and everything to the right of 100 will wind up in another shard. No manually inserting data, and we do this in a very high performance way on the back end data center. So you're not running application tier code to do these gigantic data movement operations. We're doing it for you on the back end fabric. So let's go ahead and do that split, and let's go examine the impact of that. So now when I look at my metadata, we don't have one federation member, we have two. And the first federation member, the left-hand one, goes from the bottom range of big int to the number 100. And the other one goes from 100 up to the high-end range of big int. Okay? So now we've got a new SQL Azure node out there to host our data. Now when I do, how do I get to the left-hand shard? Well, I kind of know the way my data is distributed because I just did the split. But your application is not going to know that. You're still only working with the customer ID. So you have to tell it which customer ID you want to work at, and your connection will automatically be routed to the right shard. So what do we expect now for min and max on the left-hand shard? 56 is the min, and the max? Or 99, or however it splits it, right? You got it. That's exactly it. 56 on the low end, 99 on the high end. Now we're going to route our connection to the right-hand shard. We're going to go to 100. Or let's go a little higher. Let's go 110. And by the way, customer ID 110 doesn't even have to exist, right? It's just going to take us to the shard where it should exist if it did, right? So we go in there. You going to get the hook out on me? And here is the right-hand shard. Okay? So we're starting to deliver on this concept of elastic scale in your data tier with SQL Azure Federations. This is currently in CTP. Let's just say it will be out there sooner rather than later. You won't have to wait too long for this stuff to be live. It doesn't solve every problem for you. You still have to kind of realize that your data is partitioned. We're not magically doing fan-out queries yet and pulling your data up and creating unified result sets across shards. You have to handle that in your application tier. But all the hard, heavy lifting of this kind of split type operations, We got you covered there. And this will only get better over time. You're just seeing the first wave of capabilities here. Okay? You may take a look at this and say, hey, I like it, but I need fan-out queries. You know, we need to go have that implemented first. Fine. Wait. So, hopefully you've gotten a good understanding of the capabilities of SQL Azure Database and of some of the advanced services that we're building around SQL Azure Database, like SQL Azure Data Sync, SQL Azure Federations, and it's inspired you to go out there and build that kick-butt cloud solution. So I'm going to hang out. I'll be here all through lunch. Happy to answer all of your questions. I know we're running a little bit late on time. When do we want to come back from lunch?
I would say 1:35 to 1:40.
Okay, cool. So coming back from lunch at 1:35.
Thank you, Roger. Awesome.
Yeah, thanks a lot.